Okay, well this is our coordinate geometry review, part 2. For problem number 1, if we want to determine if it's equilateral, isosceles, or scalene. Of course, equilateral means all the same. Okay, isosceles means at least 2 are the same. And scalene means none are the same. Okay, so for problem number 1, of course you do the distance formula 3 times. All of the distances are different, so that's why that is scalene. Looking at number 2. 2 of the distances are the same, 2 radical 10, but the third one is different, so this is isosceles. If all 3 were the same, it would be equilateral. Okay, now we need to slow down and do problem number 3. Students have a little difficulty with this. Look, we're told that H is a midpoint, so this is a midpoint. We're also told that G is a midpoint, so G is also the midpoint. So because of that, we can do the midpoint formula if we want to deal with H. It's just that we will be working with variables. But remember, when we talk about midpoint, it's like this. The midpoint is, it's like x plus x divided by 2, comma, y plus y divided by 2. Alright? That is how you find the midpoint. If you take the average of the x's, and that will give you the x value. You take the average of the y's, and that will give you the y value of the midpoint. So that's all I'm going to be doing to find H and G. Okay, let's start with H. Okay, let's focus on that. So, say if I want to find point H. Now, so H is a midpoint, so I'm going to do the midpoint formula. X plus x divided by 2 should give me the x coordinate of this midpoint. So the x values that I'm going to be adding up and dividing by 2 are negative 2h and 0. Look, you know what, before I do that, the word coordinates. In after school help, it came to my attention that some kids don't know what the word coordinates means. This word coordinates just means something comma something, like x comma y. Okay? When you have an ordered pair, those are the coordinates. So we're just finding the x comma y for point H. The coordinates are just the something comma something. So, in other words, we're just writing an expression for the midpoint. So back to it. X plus x divided by 2. So in this case, that's going to be negative 2h plus 0 divided by 2, comma. Now we're going to do y plus y divided by 2. Okay, this is how we find the midpoint. Okay, so now the y values. When we do the y values, we're talking about 2k and 0. So 2k plus 0 divided by 2. These would be the coordinates of this midpoint. Now here's the thing. The 0, adding 0 doesn't change anything. You know what I mean? What's 5 plus 0? 5. Okay, what's negative 7 plus 0? Negative 7. So guess what? what's 2h plus 0? 2h. Alright, so basically if you see 0 being added on the end, you can just erase it because it's not changing anything. So that's what I'm about to do right now. So I see these zeros on the end. I would just erase them right now, but I want you to be able to see what I did when you look back. So I'm just going to recopy it and put negative 2h over 2 and 2k over 2. Alright, just erase those zeros, man. That's all I did so far. But now that the plus signs are not there anymore, because if you thought I could cancel out the 2's now, oh no. You can't cancel things out if they are connected by a plus sign. But now that the 0 is gone and the plus is gone, now I kind of can. 2 divided by 2 is 1. So these 2's will cancel out and these 2's will cancel out. So that is going to leave me with negative h, comma, k. And that's it. That's as simple as this gets. These are the coordinates of h. Okay, so I can put this over here. The coordinates of h are negative h, comma, k. Alright, and that's how it's done. Now let's come over here and do the same thing with g. Okay, we're going to do g over here. For g, again, g is the midpoint. So still we're doing x plus x divided by 2, comma, y plus y divided by 2. This is the midpoint formula. So, alright, so the x's first. Okay? And you know what, look, one of my kids was confused earlier today. Wondering, well, wait a minute, how do I know to use these x values? You know, why not some other x values? Why am I not using the negative 2h now? Yeah, so just understand, if we're trying to find g, how can I make this clear? If we're trying to find g, which is the midpoint, but it's the midpoint of what? G is the midpoint of this segment right here. Okay, so I have to look at this segment if I want the midpoint is G. So I have to use A and E because those are the endpoints of this segment. Alright, it all has to be one segment. So a minute ago when I did when I found H, I had to use the endpoints A and D because those are the endpoints of the segment on which H is the midpoint. Anyways, hopefully that's clear. So back to this. So when I set up my midpoint, x plus x divided by 2, you see my x's are 0 and 2h. Okay, so I'm going to just put 2h plus 0 divided by 2, comma. Now I need y plus y divided by 2, the average of the y's. So the y values are 2k and 0. So I'm going to do y plus y divided by 2. So I'm going to do 2k plus 0 divided by 2. Alright, so these would be the coordinates of the midpoint, but we just need to simplify it. So once again, I could basically erase these zeros because they're not doing anything. So if I do that, if I get rid of the zeros, then I'm down to this, 2h over 2, comma, 2k over 2. Guess what I'm going to do now, though? These 2's cancel each other out. Gone and gone. So that's going to leave me with just h, comma, k. So those would be the coordinates of point G. Okay. Alright, so we found H and we found G. Let's go ahead and find B. Same thing. Alright, B is clearly right in the middle between these two sides. Look, we already know that the y value is going to be 0. In fact, I have space. Look, here's the bottom line. As we look at B, look at the other points. You see this? This is the x-axis right here. Can you see that point B is on the x-axis, just like all these other points are, just like D and E are? So because it's on the x-axis, the y value is going to be 0. Okay? Now, what about the x value? Okay, that's also 0. Look, it's the origin. All right, point B is where the x-axis and the y-axis meet. So this is 0, 0. It's the origin, plain and simple. So you don't have to actually do any midpoint formula or anything like that. You know, the x-axis and the y-axis meet at the origin. It's 0, 0. So we found H and G and B. That only leaves C. Okay, look, I'm going to let you in on a little secret. Finding point C, it's not that it's difficult, but it requires more information that you have to remember. And bottom line, this one's not going to be on the test. I'm just going to say it straight out. So I'm going to explain it to you, but I don't want you to stress over it because, you know, we didn't do one really like this in class. I'm not going to throw it on the test, so go ahead and pay attention, see if you can understand what I'm about to say. But if it's on the test at all, it would be maybe a bonus question. So hey, there's a reason to really listen up. Maybe you'll get the bonus question right. Alright, here's the deal. Here's the bottom line. I'm going to walk you through a chain of logic. See if you can keep up. Thing number one. Maybe I'll even number these things. Thing number one, you have to understand that okay, these lines that are intersecting here, okay, line DG, and line HE, even line AB, what kinds of lines are these? You know, like this line right here, is this a perpendicular bisector? Is this an angle bisector? Is this an altitude? Alright? Are these medians? What are these things that I'm highlighting? Okay? Those blue lines that I just traced over, these are medians. Alright? I mean, that was from the last unit, but it all ties together. It's from the last test, but it still is something that we need to know. These are medians. Remember, a median is a segment that goes from a vertex to the midpoint. Vertex to a midpoint. Vertex to a midpoint. These are all medians. Now, why am I mentioning that now? Well, when you have intersecting medians, that is a special triangle center. So this point C is a special triangle center. Which one is it? Is it the circumcenter? Is it the centroid? Is it the incenter? Or is it the orthocenter? Which triangle center is this? This is the centroid. Alright, in case you forgot, the centroid, by definition, is the intersection of medians. So this is the centroid. Now, why am I mentioning that? Well, what are the special properties of the centroid? Remember, all these special triangle centers, they have properties, except for orthocenter. But is this the one that's equidistant from the vertices? Is this the one that's equidistant from the sides? Or is this the one with the little formulas? Centroid is the one with the little formulas. Okay? Formulas like the fact that the each median is divided into a big piece and a small piece in such a way that, for example, the small piece is 1/3 of the whole thing. And so that was one of those formulas. And remember how we used to take the whole length and divide it up into 3 equal pieces? Well, look, our goal is to find the coordinates of C. That's the one thing that's left, the coordinates of C. Now here's the deal. As we try to find the coordinates of C, one of those coordinates we know right now. One of those coordinates should be absolutely obvious. Can you tell which one it is? Can you tell me either the x value or the y value right now? Think about the fact that it's on the y-axis. Because point C is on the y-axis, the x-coordinate is going to be 0. Okay? So we know it's 0 comma something because it's on the y-axis. It's not left, right. It's right on the line, so that's a 0. So all we really need is the y value. We need to know how high up this is, or at least an expression for how high up this is. Well, remember how we used to do? Do you remember how we used to divide this into 3 equal pieces? And this would be one of those 3 pieces. If we knew the whole thing was 15, for example, we would know that this would be 5. So this small piece is just the whole thing divided by 3. That's what this formula is saying. Okay? The small piece is 1/3 of the whole. Okay? It's the whole thing divided by 3. So in this case, that small piece, okay, is 1/3 of the whole, but the whole is 2k. Look at this. See this y value up here? That's the very top. And it's starting here from the origin. Okay, so 2k represents the height of the entire triangle. Alright, 2k is the whole length of this altitude. So if 2k is the whole, then this piece down here should be 1/3 of the whole. Alright, it should be 2k divided by 3. So this piece right here is 1/3 of the whole. It's 2k divided by 3. So the small piece is 2k, the whole thing, divided by 3. So it's 1/3 of it. So guess what? If this length right here is 2/3 k, then I mean, you know, if this is 2k over 3, that's how long this is, then that's the height. That's the height of this point. So that means point C is at 0, 2k over 3. Alright? Again, it's because this is the centroid. So the small piece is 1/3 of the whole thing. The whole thing is 2k. So if I divide that by 3 to get this little piece, I just leave it as 2k divided by 3. 2k over 3. Anyway, I know that was hard to understand. Probably only a few of you actually really followed it. And but let's move on. That's kind of next level. I don't want to get bogged down on it. Okay, let's move on to number 4. Centroid. When we have coordinates and we're trying to find the centroid, is this the one where we need to make all the perpendicular bisectors, or is this the one where I do the average of the x's and the average of the y's? Well, I hope you know that this is the one where I do the average of the x's and the average of the y's. So, to find the centroid, is there any space on this thing? Not really. I'll put it kind of over here. So basically, if you want to think of it this way, here's the centroid formula. I do x1 plus x2 plus x3 all divided by 3, comma, then I do the average of the y's. y1 plus y2 plus y3 all divided by 3. Okay, this is how we find the centroid if we have coordinates. And we do have coordinates, so that's what we're going to do. So here I go. So as I go to find my centroid, I'm going to do x plus x plus x divided by 3. So I'm going to do negative 2 plus 6 plus 2. Alright, so negative 2, you know what, let me do it in this order. Negative 2 plus 2, those are going to cancel out, check that out, plus 6, all divided by 3, comma. Now I'm going to do the y values. Alright, the y values are 7 and 1 and negative 5. Alright, I think we need more space here. Okay, so 7 plus negative 5 plus 1, all divided by 3 again. Okay, all I have to do is simplify this, and that'll be the centroid. So here I go. Of course, the negative 2 and positive 2, they cancel each other out. So that's just going to leave 6 over 3. 7 minus 5 is 2, and then 2 plus 1 is 3. So this is like 3 over 3. So that's why the coordinates of the centroid will be 2, 1. Okay, 2, 1. So that's it. If you're doing centroid, you just simply take the average of the x's and the average of the y's. Now, M is the midpoint of JL. Find the coordinates of M. Alright, so we need the midpoint of JL. So let's focus on that. Okay, so J and L. So this is the segment that we're dealing with, you guys. Coloring it in purple. Alright, let's find the midpoint of that segment. Of course, you know, it's all about the midpoint formula, right? Average of the x's and the average of the y's. So I'm going to do x plus x divided by 2, and then y plus y divided by 2. Let's start with the x's. So that's negative 2 plus 2 divided by 2. Comma. So that's the x's. Now I'm going to do the y's. So I'm looking at the 7 and the negative 5. Okay, so 7 plus negative 5, or I could have just said 7 minus 5, divided by 2. Okay, these will give me the coordinates of the midpoint, average of the x's, average of the y's. Okay, but let's see what happens. This is going to give me negative 2 plus 2, well that's 0. 0 divided by 2. 7 minus 5, well that's 2. 2 divided by 2. Wait a minute, is this undefined or it's 0? So this is going to be 0, 1. These would be the coordinates of M. Okay, again, the word coordinates just means the ordered pair. Something, comma, something. Okay, so that was number 4. Now, number 5. Are you scared? Don't be scared. Circumcenter. And this one was giving you guys fits in class. So we have one more chance. But look, I've made 2 separate videos on this already, so look back through the YouTube record. You will find a video specifically saying how to find the coordinates of the circumcenter. And there's a long version where I go into a lot of detail and a short version where I just do it very quickly. So please, if you are having trouble understanding from this video, this one example, go back and practice by watching the full video that's all about how to find the circumcenter using coordinates like this. Anyway, Q is the circumcenter. We're supposed to find the coordinates of Q. So, the way that you do it is by you draw 2 perpendicular bisectors. Wherever those perpendicular bisectors meet, where they intersect, that will be the circumcenter, and we can just record the coordinates. So, perpendicular bisectors, here we go. Bisectors. If something is a bisector, it hits the midpoint. So the easiest perpendicular bisector will be made using this horizontal line. So definitely choose that as one of your 2 perpendicular bisectors. Please understand that there are 3 perpendicular bisectors that we could do. There's a perpendicular bisector for every side of this triangle. But they should all meet at the same spot, so we only need 2. Hopefully this one is easy. So we found our midpoint. Since this is horizontal, a perpendicular line will simply be vertical. So let's go ahead and just draw a vertical line. Okay, so this is one perpendicular bisector right there. Okay, that's a perpendicular bisector. Just for fun, in fact, I'm going to go ahead and put this little box on here to remind us that it's perpendicular to that side right there. Now, we have to pick another side. We could either pick the LB or we could pick the DL. Either way, doesn't really matter. I think I'll wind up doing both, but I'm going to start with the LB side. So, if I want to find the perpendicular bisector of LB, again, I start by placing the midpoint. Okay, it's kind of up 2 over 1. Okay, over 1 down 2, same thing, so this is the midpoint. Now, I need a perpendicular line. Now, a common mistake kids make is they think it's just going to be down 1 over 1 every time. They just go straight through the corners and they say, ding, 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 that'll be it right there, the one where there's already a dot. Yay, I'm right? Wrong. Okay, this would not be perpendicular if I just went straight down the diagonal like that. Instead, there's a little bit more to it. You have to start by finding the slope of LB. Okay, so let's do that. Let's do what we're supposed to do. You have to start with the slope of the side that you got. So the slope is, now for me the easiest way to find the slope is just to look at it and look at the rise and run of it. So here's what I mean by that. As I go from one point to the next, like this is a point, this is a point, these are all nice even points along this side. As I travel from one point to the next doing rise and run, the rise is -2. So it's like down 2, right 1, down 2, right 1. So the slope then is -2 over 1. That's the slope of LB. Now, we need these perpendicular slope because we want a perpendicular bisector. So do you remember how to find the slope of a perpendicular line? It's got to be opposite in sign and reciprocal. That means upside down. So if this is -2 over 1, which of course normally we would just write -2, then the perpendicular line will have a positive slope. So make sure this is a positive slope. Since this is 2 over 1, then the reciprocal will be 1 over 2. So this is the slope that I'm going to use to draw my perpendicular bisector. Notice it is not down 1 over 1, okay, or up 1 over 1. It's up 1 over 2. Okay, so make sure you pay attention to that. So, starting from the midpoint, I'm going to do this slope, up 1, right 2. So up 1, right 2, up 1, right 2. So I always start off going to the right, but I also need to go to the left. So going to the left, it's down 1, left 2, down 1, left 2, down 1, left 2. Kabam! That's the answer. Down 1, left 2, down 1, left 2, down 1, left 2. I said kabam because I can already see that that's where it crosses the first perpendicular bisector. But I will go ahead and draw my perpendicular bisector by connecting these dots. Okay. Alright, so now I have my two perpendicular bisectors. Hopefully you can see that they intersect right here. Let's see, what color should I make this? I will make it purple. It didn't work. Purple. Oh, I made the line purple. Okay, anyway, this is where they intersect, right there. So that is the point 4, 5. Okay, that will be the circumcenter, so that will be point Q, which is supposed to be the circumcenter. Okay, that is how you do that. Now, I'm going to go ahead and find the other perpendicular bisector just for practice. So let's pretend that I don't already know what it is. Alright, shall we? Let's pretend that I did not pick this one. So I'm going to go back. Uh-oh, what happened to my, what was that, D? Got carried away. Erased my D. Okay. I'm going to find the perpendicular bisector of side DL now. Feel free to pause the tape. I mean, you know, if I were you, I would pause the recording and try to find the perpendicular bisector of DL myself. If you're just copying off of me the whole time, you're not really learning anything. Okay, anyway, this is good enough. So, first of all, the midpoint. There's the midpoint of DL. But then there's the matter of the slope, which I'm just going to do right here. Okay, remember, start with the slope of the side, DL. The slope of DL, look at the rise over run. All of these are points. Point, point, that's one, point, point. Every single one of these dots is a point. So as I go from point to point on the line, that's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So that slope is positive 1 over 1. So when I go to do a perpendicular, I need the slope that's going to be opposite and reciprocal. So I'm going to need negative, and then the reciprocal of 1 over 1 is still 1 over 1. So I'm going to need negative 1 over 1. So this is the slope that I will use to draw my perpendicular line. Now let me erase some of this stuff that I don't need anymore. So starting from the midpoint, I'm going to do my negative 1 over 1. That's down 1, right 1 from here. So if I go down 1, right 1, kabam! That's the answer, but I will continue. Down 1, right 1. Make a couple more. Come this way also. Just continuing the same pattern. So once again, this would be my perpendicular bisector. Okay, that didn't 100% work, but anyway, you get the idea. That's my perpendicular bisector, and once again, it meets here at 4, 5, which we already knew. All right, let's move on to part B. Find the distance between point B and the midpoint of DL. Okay, they're talking about the midpoint of DL. And they're talking about point B. Okay. So let's break this down. Whoops. Alright, so we're talking about point B. Okay. What are the coordinates of point B? Look at it. Look at it. There's point B. That's 7, 4. 7, 4. So those are the coordinates of point B. And what are the coordinates of the midpoint? Of DL. Well, let's see. Here's DL. There's the midpoint. We just got through using it. It's the point 3, 6. Okay, so these are the 2 points that we're supposed to be finding the distance between, point B and the midpoint of DL. So guess what? Just do the distance formula. Okay, x minus x, so I'm just going to do 7 minus 3 squared plus y minus y. I'll go ahead and do 4 minus 6 squared. Alright, just put that in your calculator and see what you get. I'm getting 2 radical 5. Alright, so that would be the answer to number 5, part B. Let's move on to number 6 and 7. Okay, we need to find all these question marks. Okay, so look, let's do this question mark right here. Let's not do that question mark right there. Yeah, I guess we can. Okay, here's the deal. The thing is that these triangles are congruent. So look at this y value right here, 2k. Okay, that tells us how high up this point is. So in other words, this distance from here to here must be 2k. Okay, this is like, this point is 2k high. That's what this y value is telling us. But because these two triangles are congruent, this is also going to be 2k. Okay, so that means what is going to be the total height of this whole picture? What is the total height? Alright, obviously the total height is going to be 4k. Okay, if the total height is 4k, then that means that this spot, you know, this height on the y-axis is 4k. So in other words, the y values of all of these points that are up here, the C and the A, the y values should both be 4k because that's how high up this is. So this question mark right here is going to be 4k, and this question mark right here is going to be 4k. Okay, now let's talk about the x values. Alright, maybe I should switch colors for a second. Okay, let's talk about the x values. Let me start here. Okay, well, here's the deal. maybe if I change my highlighting. Okay, now we're talking about x value. So the one x value I have right here is this negative h. Alright, negative h is the x value of this point right here. Okay, that I'm just coloring in orange. Okay, that's the x value of that point. So that means, remember, the y-axis is way over here. But that means that this distance from here to here must be negative h. Okay, this is h to the left, or it's negative h across. Okay, so that means that should be the x value of all the points on this line. This is a vertical line. So if this is negative h over, I guess I should be looking at this. If this point right here is negative h over from here, okay, like if I draw this line and it's negative h, then that means this should be, it should still be negative h up here, and it's, of course, it should be negative h down here. It's negative h the whole way. So that means this is negative h, this question mark is negative h, and it also means this question mark right here is negative h. Did I get all the question marks? I think I did. Alright, that's all there was to that. Alright, last question. Alright, well, let's start with point B. Point B here is a midpoint between A and C. Alright, so we're focusing on this segment right here. Maybe I should pick a different color. We are focusing on this segment right here. Midpoint. Alright, so all we need to do is set up the midpoint formula. So if I want to know the value of this question mark right here, it's because this is the midpoint, that should be the average of the x values. Alright, my x values are 0 and h. I'm pretty sure that's an h, not an n. So that would look like this. 0 plus h divided by 2. That's going to be 0 plus h divided by 2. Okay. Comma. Now let's talk about the y values. For this second question mark, it should be the average of the y values. So I'm talking about k and 2k. So k plus 2k divided by 2. Alright, so those should be the coordinates of point B. However, this can be simplified some. So let's see what we can do with it. First of all, that's 0. We do not need that 0 hanging around. 0 plus anything, the other thing just stays the same. So this is going to just be h over 2. Basically erase the 0. Comma. Now, h plus 2k. See if you can understand that h plus 2k is 3k. So that's 3k over 2. Now, if you're not quite understanding that, think of it this way. This might help. K is like 1k. Okay, so it's really like 1k plus 2k equals 3k. So that's why it's 3k over 2. Now that won't get any simpler, so that's it for point B. So these would be the coordinates of B. Alright, now doing point F is going to be the same thing. Okay, so let's find the coordinates of point F. So, here we go. Might need a little space. So let's do the x value first. So again, this is a midpoint, but this is the segment that I'm dealing with. I'll try green this time. Okay, point F is the midpoint of this green segment. So this is what we have to deal with. So this green segment. So the x value, so I'm talking about 0 and h. Okay, that should, the average of those should equal this first question mark. So that's why I'm going to put h plus 0 divided by 2. So h plus 0 divided by 2, comma. Alright, so that's the x value. So now let's switch and do the y values. So the y values are the k and the 0. Should equal this question mark. So I'm going to put k plus 0 divided by 2. Once again, these zeros are not really doing anything, so I can just erase them. So this is just going to give me h over 2, comma, k over 2. So those would be the coordinates for f. So remember, these were the x values of f, and this was the y values of f. So these are the coordinates of point F. Okay? Now, last but not least, we have to do point D. So here's the deal. Let's start with the x value of point D. Well, this is a vertical line, so that means that the x value is just going to be h. Do you see it? See, this x value up here is h, this x value down here is h, so this entire line has an x value of h. So that's thing number one. These values tell us that the x value is h. So it's just going to be h, comma, something. And this might be a little confusing because I know it looks like these are marked differently with a double and a single, but that was a, I think one of them just got sort of erased because of the bad reproduction. So these are, these are the same, these are the same. Clearly these are supposed to be the same. So that puts the y value should be right in the middle. Okay, it should be right in the middle. So notice that the total height is 2k. Do you see this? All right, so the total height of this whole shape from here to here is 2k. That means halfway up should be 1k, or just k. So that's going to give us the coordinates of D. If the whole thing is 2k, that means this is 1k, 2k. That's what would take us to 2k. So this height must be just 1k. That's where that came from. Alright, so that is how you find it. And that's it. That's the homework. I better stop the tape and post this to YouTube.